Hello, everyone. We are going to start our next lecture, and that's algebraic expressions. Okay, here we are going to start with polynomials. Generally speaking, algebraic expression, basically everything what you can write in math. But we are going to specify certain algebraic expressions, and we're going to start with polynomials. What is polynomial? Expression of a type an multiplied by x to the power of n plus an minus 1 by x to the power of n minus 1 plus lots of other terms, and the last term is a0, is called a polynomial. Sorry, I'll need to change a little bit my rotation of the board. So called polynomial. What is important about polynomial? First, degree of polynomial. Degree of polynomial is the highest power of x. So in our case is coefficients of polynomial are real numbers. an minus 1 and so on, a0 are real numbers. Well, basically the numbers we were talking on our first lecture. What are the powers? The powers are non-negative integers. For example, n can be equal to 2 or 3 or even 0, but it cannot be equal to a negative 1. For example, it cannot be equal to 1/2. So I'm going to write down what is possible values for n. 0, 1, 2, and so on. So n cannot be equal 1/2, or n cannot be equal, for example, -3. So non-negative integers. Well, including 0, because actually over here we are going to kind of have x to the power of 0. Example of a polynomial is 3x to the power of 4 plus 4x squared plus 1. Well, this is trinomial. Trinomial means that we have 3 terms. Term number 1, 3x to the power of 4. Term number 2, 4x squared. And term number 3 is just 1, called trinomial. Degree of this polynomial is equal to 4, the highest degree of x, right? And the coefficients are 3, 4, and 1. What we can do with polynomials? Well, we can add polynomials, subtract polynomial actually, multiply them and divide. We are going to do addition, subtraction, multiplication here in this lecture, and division a little bit later when we study polynomials deeper. So right now I'm going to subtract 2 polynomials. I'm going to label example 1 and have a polynomial x cubed minus 6x squared plus 2x, also trinomial, 3 terms, right? Minus trinomial x squared plus 4x minus 1. So we have polynomial of degree 3 cube and polynomial of degree 2. Both are trinomials, 3 terms in each, and we are going to subtract them. Before we start doing subtraction, we are going to open parentheses. So I'm going to copy my first polynomial just without parentheses because there is no sign minus in front of it, so we just can copy plus 2x, and then the minus is going to be distributed to every term of my second polynomial. So it's minus x squared minus 4x, and minus 1 are going to give me plus 1. Now, guys, we are going to simplify our polynomial by bringing the same powers together. We don't have any cubes besides the first term here, so we are just going to copy it. We do have 2 squares here, minus 6x squared and minus 1x squared. It's like you have minus 6 apples and minus 1 apple. Well, you are going to get minus 7 apples, right? Minus 7x squared. Next term is 2x and minus 4x. So you have 2 apples minus 4 apples. Well, minus 2 apples, right? So minus 2x. And the last term is just 1, and we cannot combine it with anything else. It's just going to be 1. So we simplified a result of subtraction of 2 polynomials. How do we multiply polynomials? Example number 2, multiplication of polynomials. I'm going to multiply one short polynomial of 5x plus 1 by a longer polynomial of 3x squared. Sorry, 3x squared plus 4x minus 1. So we have binomial, 2 terms here, and we have trinomial, 3 terms here. And binomial has a first degree, right? X, the maximum power of x is number 1, is 1. And here we have the second degree polynomial. So how do we kind of open this parenthesis? First, I'm going to take 5x and multiply it by every term of my second polynomial. So it's going to be 5x, sorry, it should not be this. I'm going to change my marker. I think it put arrows, too many arrows, like actually. So I'm going to have 5x and multiplied by 3x squared. That's a very strange pen I got. Well, guys, today my whiteboard somehow has changed, and I'm not very familiar with the changes Microsoft did to whiteboard, so I'm still learning it. I'm sorry if my pen is not going to have a nice color. Next, 5x is going to be multiplied by 4x plus 5x multiplied by 4x, and the last one is 5x multiplied by -1. Now I'm going to multiply by 1 each term of my second polynomial. Well, because multiplication by 1 does not change the number, I'm just going to copy everything. So it's 3x squared plus 4x minus 1. It looks like I got some kind of changeable color over here, which I really don't like because it's very destructive. So I'm going to simplify every term I have. So 5x by 3x squared. Well, first 5 and 3 are making up 15, right? Multiply them. X and x squared are going to give me x cubed. We remember that when we have the same base, the powers are added. Here, 5 and 4 are going to give me 20, and x multiplied by x is going to give me x squared. For the last term, I'm going to have minus 5x. Why? Because minus is going to just be in front, right? And 1 is going to not change 5x. Now I'm going to add last three terms, 3x squared plus 4x minus 1. Now our goal is to simplify this expression. Let me kind of push it a little bit higher so I can write down. So 15x cubed is going to stay. So 15x cubed. Then 20x squared can be combined together with 3x squared and give me what? 23x squares. 5x with minus and 4x with plus are going to be combined into minus 1x, right? Minus 5 plus 4 is minus 1. And the last term is just going to stay. So what is going to be my final result? Actually, let me double check it. I think I'm missing a minus somewhere. No, I think I'm okay. Okay, so let me just copy. Well, actually, guys, the only thing I want to change here is to erase this 1 in front of x, because usually we don't write down 1. So we're just going to write down x. And that's going to be our final answer. It's a polynomial of 3rd degree, right? And it has actually 4 terms. So let's say quaternomial. We say the polynomial was 4 terms. Yeah, I'm returning back to my black color. I don't like actually this changeable one. And we are going to move to special product formulas, guys. I'm not going to do all formulas which are in our book right now, because I think we have 3 important formulas and about 4 less important formulas. So important formulas are going to be about squares and less important formulas are going to be about cubes. Eventually in this class, we are going to learn also cube formulas. But for now, I'm going to stick to square formulas. Special product formulas. I want you to memorize these formulas if you still don't know them. So formula number 1, I'm going to prove each formula, but actually I hope that you kind of already know them. So A minus B multiplied by a plus b. I'm going to open this parenthesis using FOIL, or like I'm going to multiply a by a and by b first, a by a plus a by b, and then I'm going to multiply minus b by a and minus b by b. If you look at this expression, these two terms are identical. B by a and by b are equal, and we have a minus between them, so they cancel each other. A multiplied by a is a square, and b multiplied by b is b square. So the formula we are going to get is a minus b, a plus b equals a square minus b square. Usually, guys, I'm going to call this formula as a difference of squares. So difference of squares, okay? Formula number 2, a plus b squared. Well, I'm just again going to multiply everything. If you know this formulas well, you don't need to watch it. You can just move forward and watch next thing I'm explaining. Again, I'm going to do the same multiplication over here. So a by a, so I multiply a by a and then a by b plus a by b and then b by a and b by b plus b by a plus b by b. So what I'm going to have, a by a is a square. These are the same terms, just the order changed, right? So it's going to give me two terms like a by b. And the last one is b square. So that's going to be the formula. The formula is called a square over sum. So the square, the last operation you do, over sum, the first operation you do. And I'm going to write it down separately. A plus b squared equals a squared plus 2ab plus b squared. Also, I want you to memorize this formula. And the last formula is going to be the difference, a square over difference, sorry. Again, same, a minus b multiplied by a minus b is going to be equal. I'm going to do just multiplication like I did before. A by a, well, by then minus a by b. I put the minus in front of b, in front of the whole thing. Then minus b by a and minus b by minus b, right? Multiplication over here. So what I have, a square, that these two terms are same and they have the same sign. So it's minus 2ab. Again, because this is AB, and this, if you switch the order, it's also AB. So you have 2 times AB and the minus in front of each. And the last term is minus b by minus b is going to give me plus and b squared. So the formula, the formula is going to look like this. A minus b squared, the square of a difference. The difference between this one, right? It's a difference over squares. And here is a square of a difference. We are going to have a square minus 2ab plus b squared. Formulas 2 and 3 are very similar. The only difference between them that we have plus here and minus here, and we have plus here and minus here. Squared terms are both going to be pluses, but double term is going to switch the sign depending on what is in parentheses. Now I'm going to consider several examples. And what I want you to do, guys, try to do these examples by yourself for like 5 minutes, maybe 10 minutes, stop my video, and then like start my video again and watch how I do them, okay? So let me move it up. Okay, sorry, somehow I switched from them. So self-work. Problem 1. Well, I want you to use the first formula and simplify next expression. 2x minus square root of y, 2x plus square root of y. So I want you to use formula number 1. Example number 2, or like question number 2. I want you to use formula number 2 to simplify this expression, x plus 3y squared. And I want you to use formula number 3 to simplify this expression, x squared minus 2 squared, formula number 3. You can stop my video for like 5 minutes and try it on your own and then restart it. I'm going to make a short pause and then I'm going to count 1, 2, 3 and start solving the problem. So 1, 2, 3, and you can restart your video and watch how I do this. So according to formula number 1, well, maybe I'm going to scroll it a little bit. The a is equal to x and b equals square root of y. So I'm just going to take 2x and according to the formula, I'm going to square it and then put minus according to the formula and square root of y and also square it. Right? When I square 2x, I distribute the square over each factor. So 2 squared is 4 and x squared is just x squared. When I square a square root, I'm just going to get the number itself, right? And that's going to be the final answer. Here, I'm going to use formula number 2, and that's going to give me, this is my A, kind of my A, and this is my B. My B is more complicated, right? A squared plus 2A, B, my B is 3y, B that is not necessarily supposed to be just one expression or can be something more complicated than just one letter or one number. And the last one is 3y squared. Well, I'm going to simplify this a little bit. X squared is not going to be simplified, but 2 and 3 can be multiplied and give me 6xy. And here I can square 3 and y separately. When I square 3, I'm going to get 9. And when I square y, I'm going to get y squared. And the last expression I'm going to work is difference, square of a difference. I'm going to use the formula again, and here my A is x squared and my B is 2. So x squared squared according to the formula minus 2A, which is x squared, and B, which is 2, and plus B squared, which is 2 squared. Let's kind of, let's simplify this expression. We remember power into the power is multiplication of powers. So actually this is x to the power of 4. Here we can multiply 2 and 2 and get negative 4. Minus comes from the formula. And x squared is going to be just x squared. And here we can simplify 2 squared to 4. That's it. We solved all the problems. So now let's try factoring common factors. Another like interesting thing we can do with algebraic expressions. Okay, factoring common factors. Well, factoring common factors is operation opposite to kind of distributing actual common factors or multiplication. I'm going to show you how it works. Consider example, 5 multiplied by x plus 3. If I want to open parentheses, I'm going to multiply 5 by x and 5 by 3. So it's 5 multiplied by x plus 5 multiplied by 3. Multiplication here. Doesn't look like multiplication, actually. I'll redo it. So I can simplify it a little bit, write down 5x plus 15. Now somebody can give us this expression as initial and they'll ask us, factor out 5. What does it mean? Well, we again going to represent it as 5 multiplied by x plus 5 multiplied by 3, right? 15 is 5 multiplied by 3. And then we are going to take 5 back outside of parentheses. From the first term, we have x left over, and from the second term, we have 3 left over. So we factored it back, and we're supposed to get, of course, the same expression. Well, of course, we're not going to factor expressions like this. We are going to factor something a little bit more complicated, but the idea is the same. You find the same factors in all terms you have, and you take them outside of parentheses. Let's consider example. Example number 1. I'm going to give you a long expression to factor. 8x to the power of 4 y squared plus 6x cubed y squared minus 2x y. And they want us to factor whatever we can, like common factor. So we're going to look at each term and see that each term has x at different powers, right? The smallest power here is just x. So maximum we can factor from all factors is just x. We cannot factor x squared from this term. We can factor x squared from this term and from this, but not from this because it does not have x squared. Yeah, write down 2x better. So also there is common factor of y for all of them, right? Y is here, and y is here. And again, we can factor minimum power of a certain variable or like a number. Also, do we have 2 in every term? Yes, there is a 2 here hiding in 8 because 8 is actually 4 by 2. And 6 is 3 by 2. So we can factor 2 out of all of them. That's going to be our common factor. Now, what is left over when we take 1x and 1y and 2 from this first term? 4 is going to stay, right? We took this 2. And when we take 1x from x to the power of 4, we are going to have only 3 x's left. And 1y is going to give us only 1y left. From 6, we are going to have 3, right? If we take 2 away, we are going to have left over 3. And 1x from x cubed is going to leave us with x squared. Y squared minus 1y, not minus 1y, but take out 1y is going to give us y. Sorry, I put square here. It's supposed to be just y. And from the last term, we actually factor everything. And when we factor everything, what is going to stay? Actually, there is always a factor of 1 in every term. If you factor everything, that's what is going to stay. So it's minus 1. And we factor our first expression. Now, let's factor something a little bit more complicated. Example number 2. What if we factor not just a product or just one number, but we factor a whole parenthesis? For example, x plus 3 multiplied by x minus 5 plus 2x multiplied by x minus 5. If somebody asks us what is common factor between these two terms, you will see that it's the same x minus 5 in both of them. That's what we are going to factor out. X minus 5. More complicated expression than just 2xy, right? What is left when we take this away? Well, x plus 3. What is left from this expression is 2x. Now we can simplify a little bit expression in parentheses, in the second parenthesis I have. So we have x plus 2x, which is going to give us 3x. I wanted to write down plus 3x, but actually just 3x, right? And the last term is just going to be 3. Well, we also can factor 3 from the last parenthesis if we want, but we actually just wanted to see how to factor something more complicated. Okay, now guys, well, how else we can factor? We can factor by grouping, factoring by grouping. That's going to be my example number 3. And I'm going to write down in parentheses grouping. Factoring by grouping, it's actually some kind of mix of factoring of common factor and kind of doing one extra operation. Let me give you an example. Imagine that you have x cubed plus x squared plus x plus 1. When you have 4 terms, what you can do, you can unify first 2 terms in one group and second 2 terms in another group and try to factor something from the first group. You see that first group, both terms have x squared, and the minimum power of x here is x squared. So I'm going to factor out x squared from each term. X is going to be left from the first term, and just 1 is going to be left from the second term. Here, we cannot factor anything because x and 1 have the only common factor is 1. But what we have after we kind of look at this expression back, we have common factor x plus 1 in both expressions, which we can factor out. Let me move it a little bit this way so we can continue. So that's what I'm going to do. I'm going to write down x plus 1 as a common factor and x squared from the term number 1 plus 1 from the term number 2. So, well, factoring by grouping is first you group the terms and then you factor common factors. Okay. Well, what other ways we can use to factor expressions? Well, we can recognize our special formulas, which I was giving before and was asking you to memorize. So there were 3 special formulas and we can recognize all of them. So recognize special formulas. recognize special formulas. That's going to be the way to factor. Let me scroll up. What do I mean? For example, somebody gives you 4x squared minus 25. You can represent it as 2x squared, right? Because 4x squared, that's 2 squared and x squared. So you can take square outside. 25 can be represented as 5 squared. And then you can use the formula a squared minus b squared, which equals, well, I was giving you this formula in opposite direction, but actually it works in this direction too, right? A square minus another square can be represented as the first term without square minus the second, and the first term without square plus the second. And that's going to give us factored expression. Here, we did not do actual factoring, right? We just recognize a special formula. So that would be number one. Number two, you also can recognize a perfect square, and these are formulas 2 and 3. Let me kind of give you an example. For example, you have x squared plus 6x, somehow my pen is not working, plus 9. Well, what you can see here actually, that's x squared plus 2 by 3 by x and plus plus 3, sorry, plus 3 squared. If you recall the formula, a squared plus 2ab plus b squared equals a plus b squared, you're going to see that if you understand what are a and b here, and if they are fitting into this formula, you can represent actually your trinomial as a square of binomial. Well, let's see. So what I have, my a actually here equals to x, right? A squared is x. Then 2 is 2, a is x, and b is 3. And to check if it's correct, you look at the last term. It's 3 squared. It's supposed to be b squared. Yeah, it's correct. So we kind of factor this expression. Okay. Now, guys, can you try to factor this expression on your own? So self-work. And you can stop my video and try to do it by yourself, and then start it again and see how I do this. 4xy, that's going to be formula number 3. You just need to kind of recognize what you see in this formula and basically find the final answer. Okay, I'm going to do a little pause and then count 1, 2, 3, and then restart my video, okay? So 1, 2, 3. Well, the formula I'm planning to use is a squared minus 2ab plus b squared equals, according to formula number 3, a minus b squared. We had this formula in opposite direction. We had this first and then this next, but works in both actual ways. So if I compare these two, I'm going to see that my a is 2x, right? If you square 2x, you are going to get 4x squared. So I'm going to write down 2x. Well, this 4 can be represented as 2 by 2x by y, right? 2 is same as like formula 2. A is going to be same with 2x because I already decided that my a is 2x. And then b is y. So I'm going to put minus y. To make sure that that's correct, you are going to check if the last term is actually that b squared or y squared, and it is. Why do I have minus in between? Because formula tells me that it's going to be the minus. And the result is 2x minus y squared. One more problem to work by yourself, and that's going to be it. Okay, I'm going to label this problem 1, and that's problem 2. Can you guys use the formula 1 to factor next expression? X plus y squared minus z squared. And again, I'm going to give you some time to try and then turn on your video back and watch how I do this. 1, 2, 3. Okay, I'm going to use the formula, and well, because it's the same formula I had over here, so I'm just going to use a difference of squares. Just here, my a is going to be actually the whole expression x plus y, and my b is going to be z. So according to the formula, I'm supposed to put a, which is x plus y, and minus z, which is just like my b, right? In the second parenthesis, again, a, and plus b, which is in our case z. That's it. I did factoring. Was not too difficult. Okay. Last thing I want to teach you is how to complete the square. It's not about factoring, but it's a little bit about the special formulas. And I want you to know this, how to do this. So, well, let me just scroll it a little bit. Okay, completing the square. Okay, completing the square. Well, imagine that you have expression x squared plus 6x plus 10. You start looking at your formula like x squared plus 2x by 3 and plus 3 squared. And you see that this formula is going to make a perfect square, x plus 3 squared. But expression over here is not same as expression over here because 3 squared is 9 and we do have 10. What we always can do is this 10. We can represent this 10 as 9 plus 1 and we have x squared plus 6x plus 9 plus 1. And first trinomial is going to make a perfect square, which is going to be this x plus 3, which we already had, right? And the last term is just going to stay. This is called completing the square. And I think would be very nice, guys, if we learn this too, if you still don't know this. So I'm going to give you a self-solve problem, and try it on your own. And of course, I'm going to solve it too. What you will need to do, guys, first two terms are going to make first two terms of the formula, right? But the last term can be kind of modified a little bit. So let's try this one. Let's complete the square for 4x squared plus 4x plus 3. Okay, and a little pause, and then 1, 2, 3, and you can do it. 1, 2, 3. Okay, guys, to find out how to complete the square, I'm going to represent 4x as 2x squared. The next 4x is 2 by 2x. Well, I'll need number 3, right? The formula has 2ab. And there is 3. I don't know what to do with 3 yet. Now I'm going to write down my formula. That's xa squared plus 2ab plus b squared. And I'm going to compare. Okay, my 2x is going to make my a, right? Then this 2 is same with this 2, right? And 2x is same with a. So the only thing is left for b is 1. So I'm going to need 2 by 2x plus 1. And to complete this square, I'll need to add 1 here. Well, you can call it 1 square, but that's actually still going to be 1. To not change my expression, because I'm just adding 1 from nowhere, I'm going to just subtract it right away. And then I'm going to copy my last term, plus 3. Now, what I have a perfect square, 2x plus 1 over here. Sorry, I added 1, I guess, 2 times. Oh, sorry, that's not plus. That's not plus. That's multiplication by 1. This is perfect square. And I have these 2 terms, which I can simplify. That's 3 minus 1, which is going to be 2. So my completed square here is 2x plus 1 squared plus 2. I completed the square and have extra term. Again, for right now, there is no need in completing the square, but eventually we are going to do it. So I want you to have it in mind together with the special product formulas, because completing the square is using one of the special product formulas. Guys, there are three important formulas which we either learned today or did review today. They are special product formulas. So I want you to memorize them. They're extremely important. Okay, that's all for today. So please do your homework and see you in our next lecture.